Hi students, hope you all fine. So today we are going to discuss about fitting of exponential curve. Okay, so ఈరోజు exponential curve గురించి మనం నేర్చుకుంటున్నాము. ఓకేనా? So first let us consider the exponential curve is of the form y equals to ae power bx. Okay, we are having two exponential curves. We can say this is type 1 curve. Okay na? So now we will discuss about type 1 curve. So y equals to ae power bx. So we consider this as equation 1. Okay, so where x equals to independent variable, we call x as independent variable, y equals to dependent variable, a comma b are unknown constants. We can say that unknown constants. Okay, so these unknown constants we have to estimate now. So these unknown constants are estimated. These unknown constants or unknown values, you can say. These unknown constants are estimated by using principle of least squares. So by using this method we are going to find out the unknown values. Okay, so let us see what the principle of least square is. That is nothing but we are having two principle, that means two statements. We can write any one. So I am going to write the following one, that is the sum of squares of deviation between observed and expected values should be minimum. Okay, so this is the statement we can say for principle of least square. Okay, so by using this principle we are going to change this equation. So we are going to write this as E, or in some books it may be epsilon. So E equals to summation I equals to 1 to n yi minus so first what we have to do is, here we have to change this equation into straight line equation. Okay, it is not in the form of straight line. So we have to change this equation 1 in the form of straight line. For that we have to apply logarithms, okay, on both sides. So apply log on both sides for equation 1. Okay, so that is nothing but log y equals to log of ae power bx. Okay, so now log y equals to log a. Why? Because it is in the form of log of a into b. So log ab formula is nothing but log a plus log b, no? So log a plus log e to the power of bx. Again we can write this one log A plus bx log E, or else xb log E also you can write. Okay, so log y equals to log A plus xb log E you can write. Okay, so log y equals to log A plus xb log E. Okay, so now what we have to do is, now put capital Y equals to log Y, capital A equals to log A, x, small x equals to small x only you have to take, capital B equals to small b log E. Okay, so these values we have to substitute in this term. Okay, so that is nothing but capital Y equals to A plus capital B x. So now we can consider this as equation 2. So now this is in the form of straight line. Okay, so now we have to apply principle of least square method for this equation 2. Okay, so at that time equation 2 will be changed as E equals to, okay, or else you can write epsilon also, summation I equals to 1 to n yi minus, sorry, capital yi you have to write. Why? Because in this we are having what, capital, no? So these both the terms I am making them to bring from RHS to LHS. So we have to transfer from RHS to LHS. So that is nothing but capital yi minus a minus b small xi whole square equals to 0. Why here I have kept here square and summation in the sense, see here, sum of squares, that means what, sum in the sense what, summation, square in the sense I have keep a square. Okay, so deviation in the sense nothing but minus between observed and expected. Observed is this one, expected is this term. Okay, observed, this is expected. Okay, so between these two terms we have to take it as what, minimum. So that's why here we kept what, 0. Okay, so now we have to differentiate the above term with respect to what, a, capital A and capital B. Why? Because we have to estimate A and B, no? So that's why we have to differentiate with those terms itself. So that is what we get, dou E by dou A equals to 0, dou E by dou B equals to 0, partial differentiation. Okay, first we will take this one, dou E by dou A equals to dou by dou A, E in the sense what, we have to take this term, summation I equals to 1 to n yi minus a minus b xi whole square. Okay, this is capital, don't write small, you please make sure what you are writing, small or else capital. When you apply log, small terms will change into capital terms, don't forget this. Okay, so now this is in the form of x square. So x square differentiation is nothing but 2 into x to the power of 2 minus 1, no? So x power n differentiation is nothing but n into x power n minus 1. So in the same way 2 into x to the power of 2 minus 1. So 2 into summation I equals to 1 to n yi minus a minus b xi whole to the power of 2 minus 1. But we are doing with respect to a. So that's why a coefficient is nothing but minus 1 equals to 0. Now what we have to do is, now these two and this minus 1 becomes what? Minus 2. So we are transferring from LHS to RHS. It becomes what? 0. So that's why summation I equals to 1 to n yi minus a minus b xi whole to the power of 2 minus 1 is nothing but 1 equals to 0. So remember again, capital letters and small letters, you show the difference. Okay. So now what we have to do is we have to multiple this summation to the terms, to all these terms. Okay. So summation I equals to 1 to n yi minus summation I equals to 1 to n a minus summation I equals to 1 to n b xi equals to what? 0. So now summation I equals to 1 to n yi minus, this is constant, no? We have to write front of summation. So a summation I equals to 1 to n 1. If anything is not there, we can keep here 1, no? So minus b, we have to write front of summation. B summation I equals to 1 to n xi equals to 0. So summation I equals to 1 to n by I minus a into, so this in place of this summation we can write n. Okay, minus b summation I equals to 1 to n xi equals to 0. Now these negative terms we are taking from LHS to RHS. It becomes positive. So summation I equals to 1 to n by I equals to NA plus B summation I equals to 1 to n xi. Okay. So this is equation what? 3, I think so. Yes. Now what we have to do is, now we have to take this term. Okay. So that is nothing but dou E by dou B equals to 0. That implies dou by dou B of E in the sense what? Again we have to take this term. Okay. So that is summation I equals to 1 to n yi minus a minus b xi whole square equals to 0. So now what we have to do with respect to b, we have to differentiate. So again it is in the form of x square. So x square differentiation is nothing but 2 into x to the power of 2 minus 1. So 2 into summation I equals to 1 to n yi minus a minus b xi whole to the power of 2 minus 1. With respect to b we are doing. So b coefficient is nothing but minus xi equals to what? 0. So now only this integer part we have to take from LHS to RHS. We should not transfer this xi from LHS to RHS. Why? Because if we want to find out a, b constant, we have to make sure that this variable should not be taken from LHS to RHS. Okay. So only this integer part. Okay. So only minus 2 we have to transfer from LHS to RHS. So summation I equals to 1 to n yi minus a minus b xi whole to the power of 2 minus 1 is nothing but 1. So the remaining part is xi equals to what? 0. So now summation xi, these both terms we have to multiple with this whole term. Okay. So summation I equals to 1 to n yi into small xi, capital yi, small xi, minus a is constant, no? We write before summation a summation I equals to 1 to n xi minus summation b, first we will write b then summation I equals to 1 to n here xi, again one more xi, that is nothing but xi square equals to what? 0. Okay, so now summation I equals to 1 to n capital Yi small xi equals to, so now we are taking these negative terms from LHS to RHS. So equals to A summation I equals to 1 to n xi plus B summation I equals to 1 to n xi square. So this is equation what? 4. Okay, so by solving equations 3 and 4, so we call it as normal equations. Okay, we can say that normal equations. So by solving these normal equations 3 and 4, we get capital A and capital B values. Okay, but to substitute in equation we need small a and small b. So for that, so to find small a and small b values, we have to use the following relations. That is nothing but capital A equals to what? Log A, no? So now we want small a. So small a equals to, so log from RHS to LHS we are going to transfer. So log is nothing but it turns to anti-log when it transfer. Anti-log of capital A. Okay. Again we want small b. So b equals to what? B log E. Isn't it? Here we have taken the values, no? So these values only we are using here. A is nothing but log A, no? So that only I used here. So b in the sense what? B log E. So b equals to B log E. So now we want what? Small b. So small b equals to capital B by log E. Okay? So now A cap and B cap are best fit values. Okay, we call them as best fit values. These values are substituted in equation 1. Okay, so what we have to do? We have to substitute in equation 1. Okay, so we get y equals to a cap e to the power of b cap x. Okay, which is best fit curve. We call it as best fit curve. Okay, so like this we have to fit an exponential curve. Nothing but in place of y, we kept y cap. Y cap indicates that the value which we have find out. Okay, so b cap into x. Okay, so this is type 1 exponential curve. Now we are going to do type 2 exponential curve. Type 2 exponential curve. Okay, so let us consider the exponential curve is of the form y equals to a b power x. So this is type 2 curve we can say, or else this is type 1 and this is type 2 also you can say. So there is no specific that this is called as type 1, this is called as type 2, but these two are the types of exponential curves. Okay, so this is, we are taking it as equation 1, where x equals to independent variable, or value, independent value we can say, independent variable, y equal to dependent variable, so a comma b equals to unknown constants. Okay, unknown constants or unknown values. Okay, so these, that means a comma b, these unknown values are estimated by using what? Principle of least square method. Okay, so that is nothing but, we all know that. Here again you have to write this. Okay, the sum of squares of deviation between observed and expected value should be minimum. Again here we have to write the same. Okay, so after that, so what we have to do is, for this we have to apply what? Logarithm. Why we have to apply logarithm? In the sense, it is not in the form of straight line equation. So if the equation is in the form of straight line only, we can able to apply this one. So it is not in the form of straight line. So we have to make it as a straight line. So for that what we have to do is, we have to apply what? Logarithm. So apply log on both sides. Apply log on both sides to equation what? 1. So that is nothing but log y equals to log of a into b to the power of x. Now it is in the form of log a into log b. Log a into b formula is log a plus log b. Okay, so log a plus log b to the power of x. So again we can write this one as log a plus x log b. Okay, so again what we have to do? Put a equals to log a, b equals to log b, y equals to log y, capital Y. Small x equals to, again small x only we have to take. Okay, these all values we have to substitute in this. So we get is capital Y equals to capital A plus b and x. Okay, so this is equation 2. Now what we have to do? We have to differentiate this equation. Okay, so with respect to a and b. So now differentiate equation 2 with respect to what? Capital A and capital B. So we get what? We get two equations, that is dou E by, so sorry, here what we have to do is E equals to summation I equals to 1 to n yi minus a minus b xi whole square equals to 0 we have to take. No, so sorry, this term I forgot. So this one what we have to do? So we consider this as equation 2. Now we have to differentiate this equation 2 with respect to what? A and B. So dou E by dou A equals to 0, comma dou E by dou B equals to 0. So now what we have to take? We have to take first one. Dou E by dou A equals to 0. That implies dou by dou A. E in the sense what? Summation I equals to 1 to n yi minus a minus b xi whole square equals to what? 0. This one we have taken. Okay. So with respect to a, no, so this is in the form of x square as we discussed before. So 2 into summation I equals to 1 to n yi minus a minus b xi whole to the power of 2 minus 1 with respect to what? A, no, a coefficient is nothing but minus 1 equals to 0. So 2 into minus 1 is nothing but minus 2. So we have to transfer from LHS to RHS, it becomes 0. Okay. So summation I equals to 1 to n yi capital yi minus a minus b small xi whole to the power of 2 minus 1 is nothing but 1 equals to 0. So now we have to multiple this summation with all the terms. So summation yi minus a we have to write before minus, sorry, before summation. A summation I equals to 1 to n 1 minus b summation I equals to 1 to n xi equals to what? 0. So now here we have to write what in this place? N we have to write. So summation yi equals to, okay, so minus will keep y summation yi minus na minus b summation I equals to 1 to n xi equals to 0. So these both terms from LHS to RHS we have to transfer. So that is nothing but summation yi equals to na plus b summation xi. So this is equation what? 3. Okay, now we have to take this second one. So dou E by dou B equals to 0. Okay, so that implies dou by dou B, E in the sense nothing but summation yi minus a minus b small xi whole to the power of 2 equals to 0. So what we have to do with respect to b, so b we have to do, no. So with respect to b, so nothing but dou by dou b. So with respect to b directly I will do, okay, this is in the form of again x square, that means 2 into summation yi capital yi minus a minus b small xi whole to the power of 2 minus 1, and with respect to b we are doing, so b coefficient is nothing but minus xi equals to what? 0. Okay, so now this 2 and this minus, only this integer term we have to take from LHS to RHS. So summation capital yi minus a minus b xi whole to the power of 2 minus 1 is nothing but 1 into xi. This minus we have taken from LHS to RHS equals to what? 0. So now this summation and this xi we have to multiple with all these terms. So summation capital yi xi minus a summation xi minus b summation xi into xi nothing but xi square equals to 0. Okay, so now what we have to do? These both terms from LHS to RHS we have to take. So summation capital yi into xi equals to a summation xi plus b summation xi square. So this is equation 4. Okay. So by solving the above 3 and 4 normal equations, we call them as what? Normal equations. We get capital A and capital B values. Okay, but what we want in order to substitute in equation 1, we want what? Small a and small b. For that what we have to do? We have to use these terms. Okay, so to find small a and small b values, we use the following relations. We use the following relations. So capital A equals to log small a, capital B equals to log small b. So we want A, no? So A equals to anti-log. Log is transferred from RHS to LHS. Anti-log of capital A. This is A value. Okay, next B equals to anti-log of capital B. Okay, so like this we can find AB values. So now A cap and B cap values are called best fit values. Best fit values. These values are substituted in equation 1. That is nothing but what is equation 1? Y equals to a b power x. So y cap equals to y equals to a cap b cap to the power x, which is best fit curve. We call it as what? Best fit curve. Okay. So hope you all understand. If you get anywhere at any point, please mention in the comment. So keep watching my videos for latest updates and the next topic of semester 3 statistics students, KU or OU or SU, whatever the university it is. So please stay connected with my channel. Keep watching. Okay. So thank you. Have a nice day.